So let us look into the API flow, how the API flows goes from the user level to the kernel level. So here is my main module, which gives a call to the write file API. And since this write file API is implemented inside kernel32.dll, the flow goes inside this. So this is the write file implementation. So this write file implementation in kernel32.dll calls the NT-write file, which is implemented inside ntdll.dll. Then the sys call is called, which transfer the control into the kernel. And here is what happens in the kernel. So here is the sys call, which is responsible for transferring the control into the kernel. So in kernel, in NTOS kernel module, there is a table known as SSDT table. So basically this has the pointer to the APIs in the kernel. So basically it has the index and the address of a particular API. So here is the NT-write file API inside implemented here. And basically this SSDT table has the index and the function pointer to this one. So it will go till this NT-write file, and here it will fetch the address of the implementation of NT-write file. And from here, it goes inside this NT-write file API implementation. And from here, it goes on to the device driver, and the device driver then talks to the hardware. So this is how what happens when multiple processes are there. So a write file calls the sys call, and this one goes to the SSDT table, and similarly this write file goes here, and this write file goes here. Then the kernel takes part of the synchronization, and it sends to the file system driver, and file system driver then writes to the hardware. So this is how it goes, it works. So let us see somewhat in practical. Let me switch to my VM. So here I'm using one of the samples, which is sample 6.4 -x86 is called native. So here what it is doing is this one calls a write file at some point of time. And then yes, most important. So this is basically I'm testing it on Windows 10 32-bit. I have specifically designed this sample for analyzing in 32-bit the flow. So you can check it in 64 also, but there would be the wow 64 coming into picture. So let us see here. So here I'm in the main module. So if I scroll down, I'm going to see here the kernel32.write file. So this is the kernel32.write file. If I expand here, it is going to show me that. So this is the kernel32.write file. Right. So this one is the kernel32.write file. So I'm at this point here, 40111100, right? And if you enter here, you are going to see you are inside kernel32.dll. So you can see here the modules at the top, right? So observe the module. So now I'm in the kernel32.dll. So I am here, kernel32.dll. And then if I press enter here, or if I debug into this, I step into this, I get into the implementation of write file API in kernel-base.dll. Okay, so this is the write file implementation. And inside kernel-base.dll, if you look into the module, here is the kernel-base.dll. If I scroll down further, so let me just show you once. Yeah. Okay. So you can scroll down and see here inside kernel-base.dll, there is kernel32.dll. In this implementation, there would be a call to nt-write file or zw-write file. So you can see it here. This is the call, right? And this is the call to nt-write file, this one. And after that, if you get inside this, you are inside the NTDLL. You can see here in the top, you are in the NTDLL. And inside NTDLL, it calls, it uses this move ex comma 7. So what is 7? So 7 is the syscall number for, uh, this is the syscall number, which is meant for write file. So after this, if you check this, there is a call to this one, and this one calls the sysenter. So sysenter is the transition to the kernel. So here it passes the um, system call number, which is 7, which represents the write file, and after that it passes on the ESP also using EDX. So basically what you can say, EDX has all the parameters that is passed on to write file when you reach this point. So now let us look into the kernel part. So this is the kernel part. The lower half is the kernel part here. And kernel part, if you see, here is the NTOS kernel, which contains the SSDT table, which holds the SSDT table. So I'm using the driver, Nearsoft driver view tool to view this. And after that, this one has, so this is the SSDT table. So in SSDT table, you can see here the NT-write file is, the number is 7, which is basically the write file syscall number. And as you can say, this is also inside uh, inside this particular module, NTOS kernel. So this is how the flow happens. So let me do one thing. Let me just put it here. Just expand here and put it here. Then so if you see here, so the code flows from, so this part is the, whatever I am showing in the lower part. So this is the upper part is the user, and just this is the user part, and this is the kernel part. And your flow goes from here. It came from the, it came from the main module, then it came to the kernel32.dll, and then it went to the ntdll, and then into the syscall, and from syscall it is going into the SSDT table. So this is the SSDT table, and uh, this is the SSDT table, which is inside this NTOS kernel. Okay, and after that, the code is uh, after that it is going to get into the the code of NT-write file in the kernel, and uh, After that, it is going to the driver. It will go to the driver. Okay, so we write file code. Okay, so it will go here, right? So this is how the flow is happening from user to kernel.